So let's continue our work with looking at graphs and describing their behavior, in particular where they are increasing, decreasing, and also their domain and range by looking at example number 2, which showcases a parabola. Actually, it's a downward facing parabola. And so if we're talking about increasing intervals, we're looking at where this parabola is going uphill. What part of the graph is going uphill? And that would be on the left-hand side. So this left-hand side goes up, up, up until it reaches this vertex. That's called the vertex of a parabola. And at that vertex, the graph has a maximum. That's the highest point in the entire graph because we have these little arrows that are understood to be there, right? And so when we do the description of this yellow piece of the graph, so the increasing piece of the graph, we want to describe it in terms of the x-coordinates. And so let's take a look at what is that order pair there with the vertex. That's the order pair -2, 3. So as I look at my x-coordinates, I know that that -2, which is the x-coordinate of the vertex, that will be the largest x value in the interval where this parabola is increasing, because it's on the far right side. Okay, so that's the largest x value. What's the smallest x value? Well, because of the arrow, we know that we're coming at this from -infinity. So this parabola increases for all x values that are less than -2. And I want to remind you again that when we describe intervals of increase and decrease, these are always parentheses. We're not including the endpoints. Okay, so no brackets here. Now, where is the parabola decreasing? Well, it is decreasing on the right-hand side of the vertex, right of the vertex, isn't it? This is where the parabola is going downhill. So this is our decreasing piece. And we're going to once again describe it in terms of x values, and now that -2 of the vertex is the smallest x in my interval. Because notice that what's happening here is that we are splitting up the coordinate plane into two halves, two pieces, one that's to the left of the x equals -2 and one that's to the right of x equals -2. Okay, and so this parabola will continue to decrease for all x's. It'll continue to decrease forever, right? And so we will put here that the x-coordinates go to infinity on this branch of the parabola here on the right-hand side. And now I want to give you a warning here that even though the y values on this right-hand side of the parabola are getting more and more negative, right? Because the arrow is pointing down towards -infinity on the y values. We are asked to describe the decreasing interval in terms of x, and x is actually going towards the right side. So the x's are getting larger. So that's why this infinity here is a positive infinity, because we are describing in terms of x. Okay, what's the domain of our parabola? Well, remember, we're going to look left to right. Do we have points for every single x going left to right? And that is a yes. So the domain of the parabola is all real numbers. But what's the range? When you look lowest to highest point, what do you notice? Lowest to highest point. There is a highest point, isn't there? There is a highest point. That highest point occurs at that vertex. So we are going to use 3 as the highest y value. Notice that this is the only one of these 4 problems here, A, B, C, and D, where I'm going to describe in terms of y. The range is described in terms of y. A, B, C were described in terms of x. So I'm looking at y values now, and that range, the highest y value is 3, and there is a point there at the vertex, so it actually gets to that 3, so we are going to use a bracket. Range can have a bracket and so can domain, okay? What about the lowest point? Well, there is no lowest point, so our y values come from -infinity, and -infinity always gets a parentheses. Okay, how are you doing with that? Let's do one more example. This example 3 here, this is called an absolute value function. This is the graph of an absolute value function. So let's take a look at where this function is increasing, and it is increasing on the right-hand side here, right? It's got a minimum, so it's got a lowest point right there. And on the right side of that lowest point, and where is that lowest point? It's at -1, -2. And on the right side of that -1, -2 point, it's increasing. So as we look at x values, the smallest x value is at -1, but because this absolute value function will continue to increase forever, the x's go to infinity. Then what about the decrease? What's the interval of decrease? Yep, it's decreasing here on the left, and so its highest point, so this is the decrease, its highest point is at that -1, -2, so the x-coordinate of -1, but it's coming from the far left of the number line, so it's coming from -infinity. Okay, what about the domain? As you look left to right, what about x values having order pairs representative on the graph? It is all real numbers. So just like the parabola, it is all real numbers. What about the range? Well, because there is a minimum, right? There's a lowest point, and it does hit that lowest point. That will be our left-hand side of our range, -2. So the y values do not get any lower than -2. And again, reminding you that range is described in terms of y, looking at y values. Outputs, so -2 is the smallest y value, but there is no highest y value. So -2 to infinity.